Over the course of the 18th and 19th centuries, scientists made use of electricity, the skull's shape, evolution, and even their own eyes in their pursuit of neuroscientific knowledge. Their efforts meant that, in less than 200 years, neuroscience went from simply a branch of philosophical discussions between physiologists to a respected scientific branch. In this video, we are going to explore how discoveries in physics and biology helped them progress in their pursuits and how this research still impacts us today. We will see how disagreements became more and more common and how even science can suffer from existential crises. Firstly though, I want to point out that this video was made using the book The Idea of the Brain by Matthew Cobb as an inspiration and very much a guideline. This is my favorite book when it comes to non-fiction, in large part thanks to the way it portrays the insane amount of research it does, and making this video would be extremely hard without it. With that said, we can now begin the video by looking at electricity and the influence it had on brain research. Around the early 17th century, electricity was starting to be discussed in scientific circles. Experiments using it were common, especially when concerned with nerve and brain function, and it wasn't long until researchers found a connection between nerve functioning and electrical currents. At the forefront of this movement was Luigi Galvani, who conducted a multitude of experiments into this relationship and became one of its biggest supporters, as he observed that muscles would react to an electrical current generated by two different types of metal touching a muscle at the same time. He claimed, specifically, that what he called animal electricity could be found in most parts of animals, but more specifically in muscles, and was the same force as the one found in eels and the torpedo fish that had since been studied for decades. Ultimately, he conducted a multitude of experiments that suggested this to be the case, the most important of which showed that muscles could even react to a simple nerve. In direct opposition was Alessandro Volta, who claimed the muscle contraction observed by Galvani was simply due to external stimulation. He made this claim for both types of experiments Galvani had produced, and we now know that he was right, although he didn't know exactly why at the time. To prove this, he made up something extraordinary, a battery. Using this new invention, he demonstrated how external electricity would generate responses in his senses. Unfortunately though, he did not pursue any more knowledge in this field. But despite dropping research into this area, Volta's impact had been made. In the 19th century, neuroscientific research used and abused electricity, although clear evidence of its connection to nerve functioning was lacking. It was then that the German scientist Émile Dubois-Reymond demonstrated that this was indeed the case, although others still disagreed. Meanwhile, another German scientist by the name of Hermann von Helmholtz conducted research to uncover the speed of the nervous impulse. Through multiple different types of methodologies, von Helmholtz calculated this speed to be that of 30 meters per second, something which perplexed researchers at the time, as they did not yet realize that electricity is only part of the story when it comes to nerve communication. Another scientific development that deeply influenced how people thought about the brain and its functionality during the 19th century was Darwin's theory of natural selection. This development could especially be seen in the thinking around consciousness and how it is created by the brain, as Darwin's theory introduced the notion that humans were not different from animals in terms of brain functioning, suggesting that the difference in capabilities was a case of degree, not kind. This especially meant that humans simply possessed a higher level of capacity, although the processes which leads to this could also be seen in animals. This was such a big disruption to thinking of the time that it generated a deep discussion regarding thought creation in the brain, with Darwin and his followers, called materialists, arguing that consciousness was a byproduct of the brain's working, which all animals were capable of possessing. While Darwin's critics argued that humans were special in this regard, and that consciousness was not a product of the brain, but something more akin to spirituality and outside of human comprehension. To give you an idea of the extent that the materialist thinking reached, Thomas Huxley, Darwin's biggest supporter, once suggested that animals, and humans by extension, were conscious automata, drawing on the analogy born in the 17th century. If followed to its full extension, this idea basically suggested that we would one day create a machine capable of having its own thoughts and consciousness, and, through this, we would have a definite answer to this problem. It seems this prediction might now be closer to being proven true than Huxley himself could have imagined. This argument gave rise to an existential crisis that only deepened after Darwin's death, with many scientists of the time beginning to wonder if we would ever be able to have an answer to this question. Despite all of the advancements in research and theories, it seemed neuroscientific development had hit a wall, with further technology and evidence being needed to surpass it. This is part 2 of a mini-series I'm doing around the history of neuroscience, so stay tuned for the next one. But for now, thank you so much for not only watching, but also making it to the end of this video. If you enjoyed it, please drop a like and subscribe to the channel. As always, all references can be found in the description of the video. Take care, and I'll see you next time.